Now, as we start section 2 of chapter 4, we're moving away from graphing, although keep that as a background. But we're going to solve linear equations, systems of linear equations by substitution. So there is a protocol, there is a strategy for doing it, and that's what I'll show you. Now, as we look at our first two equations here, we can see they're not alike. And they're asking us to solve it using algebra in the case of substitution. Well, the key is that in one of the equations you solve for one of the letters, either x or y. And here we have it solved for x. So keep in mind, this is what we're saying x is. X is equal to y plus 2. Well, then I would go into this equation, and where there's an x, I will replace it with this value. So it will be 2 times x, which is y plus 2, plus y equals 10. So now I have an equation with only one variable, the y. So I can go to chapter 2 and use my techniques. Distribute, get rid of parentheses. 2y plus 4 plus y equals 10. Collect like terms, I get 3y. Transpose the 4 equals 6. Divide both sides by 3, I get y equals 2. I now have one of my ordered pairs. So if y equals 2, I take the 2 and put it right there. 2 plus 2 is 4. Now this is an easy one. It's to show you the basic technique and to understand the vocabulary of what substitution is. That is, you solve for a letter. This one was already solved for x. Take this value and put that where the x is in the other equation. You then have an equation with only one unknown. Solve that, and once you solve that, put that in either of the equations to find the other value, and there's your ordered pair. In example 2, very similar. Again, our y now is solved. So y is a 3x. So when we rewrite the equation, 5x minus, and then that's where we put in our 3x for our y, equals a negative 2. So we now have a 2x equals negative 2, x equals negative 1. We now have one of our ordered pair. This time it's the x. So if x is a negative 1, 3 times negative 1 is a negative 3. And the method we used was substitution. In the previous two examples, they had already solved for one of the letters. But here, this is in standard form. This is in standard form. But you see, what we'd have to do there is solve for x. So x would equal, we transpose that, negative 2y plus 7. So there's our value of x that we're going to put there to replace that x. And we're going to use substitution. So this is going to be 2 times, and you have to put it in parentheses, minus 2y plus 7 plus 2y equals 13. So this is a negative 4y plus 14 plus 2y equals 13. Looks like we're going to group like terms. This is going to be a 16 here. Well, that's not going to be a 16. This is going to be a negative 2y. And this goes over to this side as a negative, or a positive, no, I guess a negative 14 as we transpose it. And this looks like it's going to be a negative 1. Okay, that's good. Sometimes you can't see the forest for the trees or the numbers for what's written. And then to solve for it, negative 2, we have y is going to equal 1/2. So we have one of the members. Now in either equation, we could use this one, it was nice. So here we're going to put for y a 1/2. So a negative 2, 1/2 of negative 2 is a negative 1. So this will be a 6. And again, your skills of Chapter 2, being able to solve these equations, are going to be super useful. In example 4, we had two equations. Notice, if we're going to use substitution, we want to have an equation that has a y by itself. So here, I'm going to solve for y by transposing the negative 3x. Now I have a value for y that I will put into my other equation. There's the y, and I've replaced it through substitution with this value for y. I clear parentheses. I group like terms. Transpose this to the other side, becomes a positive 18, end up with a 4, divide both sides by a negative 2, and I get as an answer then negative 2, which is my x value. But I still didn't solve for the y value. How do I do that? Well, if this is x is a negative 2, I'm going to put a negative 2 right there. So this is x is a negative 2. 3 times a negative 2 is negative 6. Negative 6 plus 6 is 0. And this often panics students. They say, oh, it must be no solution. No, 0 is a good point. Negative 2, 0 is right there on the number line. As we do these equations, they usually are shown equation 1 and equation 2 with a big brace, indicating they are systems of equations. But we've set them up here to save a little room. This is equation 1, this is equation 2, and this one is already solved for x. So there's what x equals. So I go into my other equation, and where x is, I put this. Then I go 1/2 of 6 is 3. 1/2 of 2y is y. And my y is still there. And lo and behold, look what happens. My y's cancel out. And I end up with 3 equals 3. Now, is that a true statement? And you'll say, yes, 3 does equal 3. When you are doing this by substitution, or by the next method, elimination, which we're going to do in topic 3, and you end up with a true statement, the variables cancel out, then you have the unique case of this here, where they're actually the same equation, but they didn't look like it, did they? They were hidden. These looked differently, but when you saw, they were the actual equation. So these are the same equation. What would the answer be then? Well, you can write either of these out. You could say that x comma y is such that 1/2 x minus y equals 3. And that's how you write it. And this indicates that they're the same line. These are just different forms of the same equation. They are consistent systems, they have an infinite number of answers, and they are dependent equations because they're the same equation. Okay, now we'll go on to our next section where we use a lot more algebra to solve through the process of elimination.